Thanks so much for having me here, by the way.
Of course.
A beautiful office. Now that we don't have to walk around and move cameras around and decide where can be filmed, where we can't be filmed, we actually have time to discuss. So how do you get a job at Google while doing a PhD?
So I'm a PhD student at MIT, which is here in the background. And I also work part-time for Google. At MIT, I do theoretical physics, so quantum computing. And I do the same at Google. And,
that's the same thing I did for my PhD.
That's the same thing you did, yeah. One of my advisors is your old advisor, as you know.
Well, we worked in the same group.
That's right.
And I think you appeared in my Dana Live video at some point.
That's right, that's right.
That's where you became famous, right? I'm just kidding.
That's how I got here, yeah.
Hey, we got 500,000 views on that. So for your PhD, you're doing quantum computing.
Mm-hmm.
You also work with quantum computing for Google.
So I work on quantum algorithms. So this table is made out of atoms. Atoms are made out of electrons. Turns out these small particles, like electrons, the laws of physics at such small scales are very, very different to the classical laws of physics that we're used to. And then a brilliant scientist named Peter Shor figured out how to actually use those very strange laws of physics to solve some problems much more efficiently than you can do classically.
He was actually a guest on my channel once.
Oh yeah, I mean he's a professor of mathematics at MIT, so he's probably in the shot. He's probably somewhere sitting in the math department there.
It was the elevator pitch in an elevator with Peter Shor about Shor's algorithm. I love that so much.
So yeah, that's probably part of the reason why we're all here. What I'm trying to do in my PhD and also at Google is trying to find new algorithms, so-called quantum algorithms, that can exploit these very strange laws of physics, of quantum physics, to solve some useful problems much quicker. Physics at this quantum level is very counterintuitive. So you have things like superposition. So roughly speaking, a particle can be in two different positions at the same time. And you have other things like entanglement, like long-range correlations. You have to somehow design an algorithm that tries to exploit these weird things to solve some problem that people actually care about very efficiently. And yeah, that's the main challenge I'm working on. And a lot of people at Google are working on similar topics, which is why I work with them.
You know, one thing I like to explain this to people is as follows. So let's say I want to calculate something that may seem quite simple, but just the speed of the serviette falling down. And you can do it approximately quite easily, but there's wind resistance, there's so many factors, it's very hard to actually make an exact calculation, and the more exact you want to get it, the harder it gets. But nature doesn't need to do this calculation for it to just drop, right? The laws of physics just make it fall. And the way I sometimes think about it is, with quantum computers, instead of doing the calculations like you would do in some fancy NVIDIA GPU, you could sometimes, at least in theory, if you had good quantum computers, you would just let the laws of physics find the minimum energy state of some problem, and then just by things happening to the laws of physics, you're basically solving a problem.
That's right.
It's kind of a way that I like thinking about it.
Yeah, another example is if you have a prism and you shine light through it, it splits the light into all different colors. So it does effectively a Fourier transformation. Yeah. But it does it in real time. You don't have to...
Instantly. There's no calculation that needs to happen for it.
We're trying to use the fact that physics naturally computes things. They naturally compute equations of motion. We're trying to sort of design a physical system such that the equations of motion match some calculation that we're actually interested in. And if you do that at the quantum level, turns out it becomes much more difficult, but also much more powerful, which is what we're trying to do.
A bit of bone. Does Google not have boneless chicken? And is your MIT research connected to the Google research, or are these separate projects?
So they are on the same topic. So I try to solve the same problem, but they're separate. So I'm always working on quantum algorithms, but the quantum algorithms I work with for Google are different than the ones I work with at MIT.
Yeah, and you can't discuss it because it's Google after all, not a...
I can't
not
discuss
academic.
any details.
Yeah. Do you still work on the same research that did at Google in Venice?
That's right, yeah. So before I started my PhD here, I used to work for Google for 1 year in Venice Beach as a student researcher, so a kind of an intern position for researchers.
By the way, for those who don't know, the Google Venice office, I wanted to work for Google not because of Google, but because right next to the Google Venice office, there's Gold's Gym. If you watched my first episode of my Startup Vlog series, I actually going to Gold's Gym where Arnold works out and all these people. His office was right next to it. I'm so jealous about that.
That's right. Yeah, you could see Arnold still goes to that office.
Yeah.
Like, in the mornings. So sometimes
You mean to
could
the
see
gym
him-
or to the
gym,
Google
to the
office?
gym.
I don't think he comes to the Google office.
Actually, I think the gym, the building itself, is owned by Google.
Really?
They sublease it to Arnold.
That's so nice.
And yeah, it's right at the beach. They have like surfboards in the office that you can just take and go surfing every morning. So that's what I did a lot during that year living in LA.
Let me ask you a reasonable question. What the hell are you doing here? You have the beaches, the gym, the beautiful office there. What made you come to Kendall Square here at MIT?
Well, it's this thing, it's MIT.
MIT is quite nice.
Yeah, I'm doing my PhD here. I'm very happy here.
It's a beautiful place.
It's a great place to do research. Yeah, and I got very lucky that like this deal kind of worked out. I can still continue working with Google.
Oh yeah, it's amazing.
Yeah,
and I mean, I love being here too. I'll probably not be here for a long time. I'll probably end up moving to San Francisco eventually, but for like research and like Harvard and MIT are here, and it's really just beautiful. People sometimes imagine that Boston is this big, ugly city. It's actually really nice.
Well, we did pick a good day to film it because it's like autumn right now, but
yeah.
in
I'm
winter
saying
it
that
does get-
forgetting about my winter traumas.
Yeah.
It's okay. I'll spend my winters in some nice island this year. I no longer CEO of my startup. I don't have to be here anymore. It is really nice. Like I always heard from people and my friends who would move there after graduating. They would say like, yeah, it's better for startups. And I'm like, what do you mean it's better? Like, sure, maybe more people work in startups, but I can talk to the same VCs here. Everything is the same. It doesn't make a difference. We're like, no, but trust me, it's better. And now that I went there, like myself, for a week, I realized what they're talking about. It's really almost like a magical thing about different places that make you become better at the thing that place is specialized in. So here, everything is about being smart, about being academic, and it's well respected, and everyone you talk to, they will be excited about what you're working on. But if you went to, well, for example, LA, and talk to some random LA people who don't work at Google, they'll be like, yeah, quantum computing, yeah, whatever. How many followers do you have? It's like that kind of thing. And in SF, it's all about startups. Like when you go there, people are all working on their startups. You just hear everybody talking about this. And it's just interesting how, you choose what you want to do in life, and you can go to a city that's going to help you become so much better at that specific thing. And for that, Cambridge is amazing.
Yeah, I agree. Yeah.
What is topological quantum computing?
Topological quantum computing.
Does that exist? I just threw together some words here. No, I mean, I do know that there is something between these two things.
I work to some extent on quantum algorithms for problems in topology and algebraic topology. That's different to topological quantum computing. Topological quantum computing is like trying to build an architecture that's where the building blocks of your device, so the qubits, have a topological nature to them, and that's good for like error correcting reasons.
Yeah, but we can't build it.
I mean, it's not built yet in a.
Or we're gonna have a long compilation of Sascha chewing on camera. You know how you can cut together things like I ask you a question and then you just go like, and I ask you the next question, you just go. We'll do that. Yeah, I'm really curious to hear about your day-to-day routine. So you wake up, do you go to MIT, to Google, or do you do both?
Most of my day is just having meetings, doing research. So I usually wake up, I have a bunch of meetings from home. I usually spend a lot of
Where do you live?
Oh, I live next to Harvard, at Harvard Square.
I heard you have a very nice apartment.
Yes, so I'm actually living in your apartment, in your old apartment. Sorry.
So if you want to watch a tour of his home, it's on my YouTube channel already.
Yes, but I'm not in his room, not in Samuel's
different room, yeah.
Yeah, which is a beautiful location, so I can really focus well there. Then I usually go to MIT. Sometimes I just work from the office there. Sometimes I have class. Sometimes I meet other people there, meet my advisors. I come here for lunch. I have some meetings with the Google team, usually. I go back to MIT.
Do you have to work basically twice as much, or does your one research count as the research somewhere else too?
It feels more like working twice as much. Yeah.
Because doing one MIT PhD is too easy, right?
Well, it's just
anyone can do that.
The lunch is too good to miss out. And then in the evening, it's usually, so I'm part of a lot of clubs. Actually, I just founded a kitesurfing club at MIT with some friends. So this is the Charles River. You know, it would be perfect for kitesurfing. You can windsurf there and everything. There's strong winds.
You could jump over that bridge.
Well,
if you
the
had
thing
the balls
is,
to do it.
the thing is, someone tried to do that and they didn't make it, and that's why kitesurfing is not allowed anymore in the river.
What happened?
So, well, the wind stopped and they landed on the bridge, and
Oh my goodness.
there are cars on the bridge.
Is there a news article?
So some police officer told me that because I was trying to kite there, and they were like, no way.
How did they tell you? You were like out there in the middle of the river?
No, I was like on the shore setting up my stuff.
Oh, and then the
they
guy
stopped me.
walked over to you.
Yeah.
Do you have some spectacular footage of you kite surfing?
I do have footage of me kite surfing, yeah.
Can we show it?
Yeah, of course. I'm trying to get a petition together to legalize it again. We already have like 350 signatures, I think. So, and we only need 500. So
Can I sign too?
you can sign, yes.
That's very nice though. I love going sailing here, but I haven't learned to kite surf yet, but I was supposed to fly out to the Philippines yesterday.
Oh yeah, what happened to that?
Well, because of the home purchase. It was
Ah.
like a last moment thing, and now I have to deal with the home purchase, and I have to be available. And you know, if I'm on some tropical island with no signal, that would cause a lot of trouble.
What was your plan there? Just vacation?
I had no plan. I literally just booked a one-way ticket, and I was like, I'm just gonna go around the country and explore and see all the beautiful nature. Now that I'm unemployed. So you're doing 2 jobs. I'm doing no jobs. So on average, we each have a job.
For average
We're good,
employees, yeah.
Actually, it's such a weird feeling. I need to get a job. Can I come here every single week with you, Neat?
Unfortunately not. I can only bring 2 guests a month.
2?
Yeah.
Like twice or many times?
No, twice a month. It's like the common rule for all Googlers, and then...
Sascha, can we have this tradition in every single vlog? I somehow end up in a gym. But I heard we can't access the Google gym. Can we
The
get a
gym here
sneak peek of it?
It's only for employees, so I can't show you, unfortunately.
Can I look at the dumbbells?
It's not like even the room, the way the entry room is like off limits. So I'm
Damn
sorry.
it. I'll do a workout in my home gym, just to wrap up the tradition. I really want to work for Google in Venice now.
Yeah.
How can I get a job? Well, it's too late. I quit my PhD that could have gotten me there.
I'm sure you'll find a job if you want to.
It will be fun. Now's the moment for me to drop all of this. Shifting.
Put it there. It's some kind of mango vanilla smoothie.
Oh, I'll take that. This is the protein cookie. Is that mine?
That's fine.
Oh, that's yours. This one's mine. Oh, I got a bigger one. This is public.
This is coming, yeah.
Anybody can go here.
Anyone can go here. Anyone can play paddle tennis.
Do you want to know why all of this is public? Because when Google wanted to get their permit to have their fancy building here, they had to negotiate with the city, and the city was like, you need to give us something. So they gave the city this. It's pretty nice though. Congratulations, you made it to the very end of this special video. And if you want to see some more podcasts with fascinating people doing their PhDs at MIT who have worked at Tesla or won incredible physics, math competitions, you can check out some of my podcasts over here, here, and here. Thanks for watching this special, and I'll see you next time. Take care.